Hello, 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 and welcome back to the Outward Stream. Today we are going to be looking a lot more at our measurements that we had last time. Remember last time on Tuesday we were able to basically isolate exactly why we were seeing so much error in that one measurement, and after a whole lot of thinking we were able to finally, hopefully, fingers crossed, come up with a appropriate way of measuring large distances away from us without having to physically roll there, which would be real fantastic if we could get that done. Oh, it does have an if statement. So yeah, if this equals 0, oh my goodness. Oh, Google Sheets needs to get its sheet together. So yeah, that should make sense. Let's do this. Instead of E4, let's put something I know isn't 0. C2. Okay, yeah, we're good. We're good. I still got it. We had our blocking wall that we couldn't get past. We had our close object. We had our one measurement that we knew. We had another measurement that we knew. This was a 90-degree angle. This was our y. This was our x. And we had these dotted lines that represent measurements that we took. And what are the measurements I'm talking about? Well, I'm talking about measurements that I forget the name of. So first, this is why you need to write things down. Monk, you keep forgetting to write things down, and it is just causing every bad thing to happen all at once. Is if you zoom out, you'll see that it's going towards 0 as we get bigger and bigger. It'll never reach it though. And that's because simply, if you plug in large numbers for x, you know, it's going to get smaller and smaller and smaller for y, but it's going to approach y, right? It's going to approach y equals 0. The opposite is true when x is small. Y will get big, and y will get big fast. That's what this is happening. And if you have errors in x, even if they're incredibly small, they become unmanageable when x is smaller than something like 0.5. In our case, x is 0.001. But we have two unknown sides, right? These are both lengths that we can't know. No matter what we do, no matter what triangle we make, we will never know either of those sides. So we're forced to use the law of sines. Well, we're not forced to use the law of sines. There's another method that I'll go over shortly that we will think about, I think, for a while before completely abandoning our attempts at measuring long distances, because that would be so useful. But as long as we're dividing by a really small number, we're going to see incredibly large errors, no matter how accurate our angle measurement is. Yeah. So, how do we go about doing this? Well, let's go back to our notebook. That's where mistakes are meant to be made. So, we might end up having to actually roll across this entire map. Because it's the only side that I know. And actually, I probably could have saved my skin with all this nonsense. If I go back over here, I think it was doomed from the get-go. these are proportional, right? The proportions have to be the same. So it makes sense that if you have a small side, it's going to be a small angle. So if I want a big if I want a big angle, I need to measure one of the big sides, which defeats the purpose of this exercise, kind of. Oh. Tragic. Truly. Learn. It's good for you. Trust me. I'm a random person on the internet. Put all your faith in me. If they do change, wow, that's going to be incredibly difficult. But, anyways, the reason I want to go to the docs is because I want to see if we can possibly measure the distance between that rock and us. And the reason I want to know that distance is because we need to know that distance if we're going to have a help of calculating the height. It also, is just helpful to be able to measure the distance to things. Now, how are we going to measure this distance? Well, before, let's go over our previous methods, right? Our failed attempts at measuring that distance. Let's bring out our notebook, our handy dandy notes, and then we had this. So that should be incredibly small. Why? There we go. Gotta get that notebook. I just looked at the chat. That was very nice. But, yeah. And then we'll see which one's more seemingly accurate, and we can settle on that for now. So, what do we want to measure again? We wanted to measure the angles again. So, the first angle I'm going to remeasure is going to be theta 2. So, theta 2 was over here. We measured it from here. And we said, oh, I need to move the backpack because we don't know where east is. Okay. That was excellent. That was definitely worth the move of that backpack. God, that did nothing. Degrees. It's a shift of 33 degrees, so if we had to draw the parallel between, the two right triangles, let's head back into the house and I can show this to you on the notebook, what I'm thinking about. Okay, now that we're back in the house, all tired, tuckered out, let us return to our notebook. That's not our notebook. I will use it only on, I think, large monuments, things that are easily measured by lots of people, and then perhaps other people can also take measurements, and we'll see how close everyone gets. And after 10 people or so get the measurement, we can take the average and say, yeah, that sounds about right. Eventually just ask the developers to give us the Unity code so we know how tall the mountain is. Anyway, that I think is going to call it for the stream. I think we're at a good place for all these measurements. We're going to start moving on. We're going to start cataloging the rest of what was in Cierzo and start heading out, start exploring. Man, I'm doing my whole thing about saying goodbye, and I have the notebook in front of my face. Unbelievable. But that will be it for this week. A video will be up either Saturday or Sunday for the highlights. Anywho, I hope you all have a fantastic weekend. Enjoy the last day of the week tomorrow. Hopefully you got big plans, some COVID friendly plans. Still got that going around, so make sure you're staying safe. Anywho, I will talk to you later.